Baseball is popped up. Let's draw a little picture here. Baseball gets popped up. Person batting baseball. There's a bat. Baseball goes up. Here's this light tower. That's supposed to be a light tower, not an alien, right? So the baseball goes up and then comes down and hits the top of the light tower, right? And this distance here is 23.8 meters. Right, it's above. Let's see. It's in the air for 4.75 seconds. What velocity does it strike the tower? Down is negative. Okay, so I think these guys we can solve with 1 suvat. So let's do that. Let's go from here to here. And let's do that with 1 suvat. And we can, even though it goes forth and back, and there's this thing in the middle there, our equations can deal with that. Right? So our net displacement is up 23.8. That's not the distance it traveled. It traveled a greater distance, but the net change in position, which is what S is that we end up 23.8 meters higher than we were going, right? We don't know the initial velocity. The final velocity, we don't know that either. It's like, how can this be done, right? The acceleration is negative 9.81 meters per second squared, and then the time is 4.75 seconds, right? Now, we don't actually have a formula that will find our final velocity, but we do have one that will do this, right? So let's, S is u t plus 1/2 at squared, and so it looks like we can find u from this, right? So 23.8 equals u times 4.75 plus 1/2 negative 9.81 times 4.75 squared, right? Okay, so hold on. 23.8. I'm going to add this on there. Plus 0.5 times 9.81. 4.75 squared, right? Is that, and then I'm going to divide that by 4.75. I get 28.309. So my initial velocity is 28.30927. That's got to be enough sig figs to carry along, right? And it's positive, right? This formula actually gives us a correct number. So I'll just say, how many sig figs do we have? We have 3. I'm going to say 28.309. Okay, and that's meters per second. Then it says, with what velocity does it strike the tower? Well, I can use just v equals u plus at, and I don't really have any other choice for that. This is an a. Okay, so final velocity is 28.30927 plus negative 9.81 times 4.75. Okay, I'm going to store that number so I can use it. Okay, so now I'm going to go minus 9.81 times 4.75. Negative 18.28. So the final velocity is negative 18.288 is what it really is. So what is the initial upward velocity is plus 28.3 meters per second. The downward velocity that it strikes the tower is negative 18.3 meters per second. And then the greatest height the ball reaches, we would have to re-suvat. So I'm going to erase everything here, and we're just going to do another suvat here. Okay, we're going to use this 28.30927. Okay, so now it's like the ball goes up and it goes down and hits the light tower, right? Type of thing, right? But we want to go from here to here, right? And so the final velocity is 0 at the top, right? Because it's at the top. It's at the top. All right, the initial velocity is this guy here. I'm going to use 28.30927 meters per second. The acceleration is negative 9.81, and we just want s, right? So we want to use no t. So 0 squared is 2 times s. Okay, so this guy, 28, okay, I'm going to square that, divide by 2, divide by 9.81. And I get 40.8468. Ta-da. Yay.